Hello everyone, my name is Ibrahim bin Othman. Today I'm gonna talk about Module 3 Communication in Distributed System. The objective of this module is to identify different layers of communication from protocol to application programming interface APIs, to present the various ways and widely used models of communication in distributed systems, to specify different paradigm of communications, and to be able to program application with distributed object and internet protocols. The overview of this module is protocol, models including remote procedure call, remote method invocation, message-oriented communication, stream-oriented communication, topology of communication including client-server, peer-to-peer, and group. Now we're going to discuss about OSI layered protocol. The OSI layered protocol consists of 7 layers. The first layer is physical layer. Physical layer transmits raw bits over a physical medium such as cable, microwave, or fiber optic. Convert frame to electronic signal, pulse, or other physical form, and the reverse. The second layer is data link layer. Here, it provides an interface to a communication medium on the physical layer. Changes packets of data into frame and vice versa. A frame is the elementary unit of information transferred across the data link layer. Packets are contained with frame. The data link layer may provide error detection and correction. The third layer is network layer. Network layer routes data between adjacent or local network devices in the form of packets. A packet is fundamental units of data transmitted between network layer on two nodes. The fourth layer is transport layer. Transport layer accepts data from the session layer and determines how to present it to the network layer. It takes data from the network layer and redistributes it to appropriate application or other entities on the upper layers. The fifth layer is session layers. Session layers negotiate and manage communication sessions between network processes. The sixth layer is presentation layers. Presentation layers perform services generally required by applications such as data conversion, encryption, and compression. The seventh layer is application layers. It serves the application process, providing features such as file sharing, network transparency, and distributed processing. Here is the protocol used according to the layers. Remote Procedure Call (RPC). RPC is a request made by a process in one computer to another computer across a network. RPCs tend to operate in real time because the calling program usually waits until it receives a response from the call program. In this respect, RPCs are synchronous. RPCs are required in applications in which a procedure should not continue until it receives the information it needs from the remote system. Client-server applications use RPCs. The idea behind RPCs is to make a remote procedure call look as much as possible like a local one. The basic idea is to execute a procedure at a remote site and ship the result back. The goal is to make this operation as distribution transparent as possible. Steps of remote procedure call (RPC). A remote procedure calls occur in the following steps. First one is client procedure calls client stub in a normal way. Second, client stub builds message call local OS. Client's OS send message to remote OS. Remote OS give message to server stub. Server stub unpacks parameters, calls server. Server does work, return the result to the stub. Server stub packet in it message, call local OS. Server's OS sends message to client OS. Client OS give message to client stub. Stub unpack result return to client. The definition of client and stub are additional functions which are added to the main function in order to support RPC. Here is the view of how client and server stub work. Asynchronous RPC. Avoid blocking of the client process. Allow the client to proceed without getting the final result of the calls. In A, you can see the interconnection between client and server in traditional RPC, while B, the iteration using asynchronous RPC. Deferred synchronous. One-way RPC model. Client does not wait for an acknowledgement of the server acceptance of the request. The figure shows how a client and server interacting through two asynchronous RPCs. Remote Method Invocation (RMI). RMI is the basic distributed object computing in the Java environment. RMI defines how Java components and interoperate in a multiple Java virtual machine environment. RMI provides the tools that programmers need to create distributed Java application, which is objects that can invoke methods on other Java applications that are running on the Java virtual machine, such as remote hosts across the internet. Invoking is a method is like asking another program to do something. The primary difference between RPC and RMI. RPC used for procedure, which is base application. RMI is used for distributed object system. RMI is object oriented while RPC is procedural. Remote distributed object. Objects separate their actual implementation from the interface. Distributed object, an object which publishes its interface on other machine. Remote object, a distributed object whose state is encapsulated. Java RMI. Distributed object integrated into the language. The goal is to achieve transparency. Any serializable object type can be a parameter to an RMI. Local objects are passed by value, remote objects are passed by reference. Proxy can be used as a reference to a remote object. Possible to serialize the proxy and send it to another server. Here how Java RMI works. Summary. RMI is specific for a remote object. Remote objects offer better transparency. RMIs allow object reference to be passed as parameter. Local objects are passed by value. Remote objects are passed by reference. That's
Now we will talk about message-oriented communication. RPC or RMI are also known as request or response. If we assume that there are no response, we move into message-oriented communication or MOC. MOC is typically more decoupled than RPC or RMI. Here we can see persistence and synchronicity in communication. General communication system connected through a network. Each host is connected to a single communication server. Host and communication server can have buffers. Now we want to differentiate between persistent and transient. Persistent messages are stored as long as necessary by the communication system, for example email, while transient messages are discarded when they cannot be delivered, for example TCP/IP. The difference between asynchronous and synchronous. Asynchronous sender continue after submission, while synchronous sender is blocked until message is stored at receiver's host, message is received, and response is received. Here we can see the example of persistent asynchronous or synchronous communication. Figure A shows persistent asynchronous communication, while Figure B shows persistent synchronous communication. Next, Figure C shows transient asynchronous communication, and Figure D shows receipt-based transient synchronous communication. And other transient synchronous communication, the Figure E shows delivery-based transient synchronous communication at message delivery, while Figure F shows response-based transient synchronous communication. And now we want to talk about topology of communication. The client-server model underlines almost every distributed system. Hence, it is important to understand the principle of client-server communication. In quality of service, we have 4, which is exactly once, at most once, at least once, and maybe. In exactly once, the services is executed once and only once, while at most once, the service request may or may not be or have been executed. If the service is not executed, the client is being informed of the failure. At least once, the call may be once or more than one time. And the last is maybe. It is neither guaranteed that the service has been executed, nor is the client informed of failure occurrence should there be any. Now we want to talk about quality of service. In quality of service, we have 3, which is request protocol, request reply protocol, and request reply acknowledgement protocol. Request protocol, if the client can cope with the maybe quality of service, the client may not want to wait for the server to finish the service. This protocol, however, is unsuitable if the service has to return data or the client has to know what happened to the service execution. The advantage are that is only one message involved, thus the network is not unnecessarily overloaded and the client can continue execution as soon as acknowledgement of message delivery has been returned. In request reply protocol, to be applied if client expects result from server. Client requests service execution from server through request message. Delivery of service result in reply message. If the reply message is not received, after a certain period of time, this can have many reasons. The server has not finished the execution yet. The reply message has been lost, maybe. Server therefore keep a history of reply message and client may resend the request and the server then resend the reply. For request reply acknowledgement protocol, depending on the amount of client-server communication cycles, the maintenance of a history may involve a serious overhead. The RRA protocol is designed to limit this overhead. RRA adds 2 RRN additional acknowledgement message which is sent by the client as soon as a reply has been received. The receipt of an acknowledgement message enables the server to dump the reply message of that communication cycle and all previous non-acknowledgement reply. Point-to-point communication or P2P always involve exactly two processes. For example, MPI send buff count data type dash tag com. Dash is identified by its rank within the communicator. Com identifies a group of process and a communication contact. MPI RECV is a buff count data type source tag com and status. Several variations on how the sending of a message can interact with a program. This is the example of synchronous. A synchronous communication does not complete until the message has been received. For example, a fax or registered email. This is asynchronous. An asynchronous communication completes as soon as the message is on the way. For example, a postcard or email. The blocking and non-blocking. Blocking operation only return when the operation has been complete. For example, normal fax machine. Non-blocking operation return right away and allow the program to do other work. For example, receiving a fax. Group communication. Group communication we have two, which is client-server request and sometimes other properties are required. For client-server request, the communication pattern that we have seen so far was bilateral, in the sense there were only two parties involved, client and server. Moreover, it was intimate as the client component always had to identify the server component. Sometimes other properties are required, communication between multiple components and anonymous communication. Now we see the concept. First is broadcast. Broadcast is send message to a group. And another concept is multicast. Multicast send message to subgroup only. Okay, that's all.